Today's question, construct quad tree. Given an n times n matrix grid of zeros and ones, so it's the same length and height. It's a quad tree. So quad tree representing the grid, return the root. Notice that you can assign the value of a node to true or false when isLeaf is false. And both are accepted in the answer. Okay. A quad tree is a tree data structure in which each internal node has exactly 4 children. So one root and there are 4 children. Okay. Besides, its node has 2 attributes, value is leaf. Okay, so it has to have 4 children or no, nothing. So top left, top right, bottom left, bottom right. Okay, so it's more like so the visualization is more like there's a root here, top left, top right, bottom left, bottom right, and there are 4 children. Okay. So we can construct a quad tree from a 2-dimensional area using the following steps. If the current grid has the same value, all ones or zeros, set isLeaf true, and value to the value of a grid, set the 4 children to null and stop. If the current grid has different values, set isLeaf to false and set val to any value and then divide the current grid into 4 subgrids as shown in the photo. Recurse for each of the children with the proper subgrid. The output represents the serialized format of a quad tree using level order traverser, where null signifies a path terminator. No node exists below. It is very similar to the serialization of the binary tree. The only difference is that the node is represented as a list isLeaf and the value. If the value of isLeaf or val is true, we represent it as 1 in the list. And if the value of isLeaf or var is false, we represent it as I have no idea what this structure looks like. So I'm gonna take a look at the example here. Okay. Let's see. So grid. So let's say we are given 0, 1, 1, 0. The explanation of this example is shown below. Notice that 0 represents false and 1 represents true in the photo representing the quad tree. So isLeaf is 0 top left, top right, bottom left, bottom right. So when the value is 0, the leaf is 1. Okay. Let's read the quadtree format again. The serialization. If the value of his leaf or var is true, we represent it as 1. So value could be 1 or his leaf could be 1. Let's look at this example. If all the values are top left, it is leaf and the value is 1. What about top right? Top right is actually divided into 4 different quad. Bottom left is all the numbers are the same. Bottom right, all the numbers are 0, so they're the same, and the leaf. Wait, so if all the numbers in the quad is the same, okay, so if the current grid has the same value, I see. So let's say if we are given this grid, if they're 1 1 1 1 or 0 0 0 0, they are actually, so these 4 are the same. Okay, and these 4 are the same. So this is leaf and value is 0. This is also leaf and value is 1. Because they have to be the same. Okay. If the current grid has different values, set is leaf to false. Yeah, that's what is happening here over here in this example. So I'm actually going to copy this into here and annotate here. Yeah, because okay, so this portion, the top right portion, had 0s and 1s. So they couldn't be a leaf. So that's why we have this is leaf to 0 on the top right. The value, I think it said it's okay to be value 1 or 0, but let's check it. True, the value is true if the node represents a grid of 1s, or false if the node represents a grid of 0s. So I think true and false basically means 1 and 0. Okay. Is leaf true if the node is leaf node on the tree? False is if it has 4 children. What happens to the value? What's the value of non-leaf node? If the current grid has different values, set is leaf to false. Yes, that's what's happening over here. And then set value to any value and divide the current grid into 4 subgrids. Okay, value can be pretty much anything. So value can be 1 or 0 over here. Okay. So I think I understood what the problem is asking about. So first of all, we need to divide a grid into four quadrant, and then determine if each of them have different values. If they have the same values, then they can be a leaf node, and value can be its value. Okay. Well, this feels like very recursive in nature, where there are the horizontal, the x-axis range, and there is y-axis range. So row range and column range, and there will always be the midpoint. So we can call the same function to divide divide into the quads, and pass only the top left section, also the top right, bottom left section, and so on. And whatever it returns will be the parent node of the quad for children's. Or if it is a leaf node, then it will be its own leaf node, its own node. Okay, so initially we are given this grid array, two-dimensional array. That means we will call recursive on 4 different quadrants. One will be the row start, row end. So that means horizontally, or row, the beginning of the row and the end of the row. And then there's also column start. Oh, actually, row will be this vertical direction. This is row, and this is column. And then there's also call end. Okay, and we are going to call this 4 times. And then the node we get here will be tied to the parent. And we can continue running until the base conditions will be when all values are the same. This means it is a leaf node. Another base condition. I think this base condition will basically solve all the base conditions, because in the end, when we are left with only one element each, okay, in this first example, they are actually left with single values. That means those will eventually be leaf nodes. no matter what. So this, when all values are the same, will also account for when there's only a single value in there. Okay. And once those are returned and built, what do we need to return? The output should be level order traverser. So it starts from the parent, okay, and then there are 4 children. So it is very top left, top right, bottom left, bottom right. And what we print out is whether it is a leaf node or not, and its value. So once we build this final quadtree structure, we are printing that. Okay. When printing things out, I will need to put parent and then their children first. So using queue, put all them into the queue as we print them out. Okay. So we got the base condition. We know what to call. So row start will be initially 0 to the length of the array. So n, 0 to n minus 1 will be the length or the range we are passing in. That will be divided into 2. And then the node returned. Then the question becomes, how can we effectively determine the space condition? Do we have to go through individual cells and determine if they are the same number? Can there be a lot faster way? Because then you're basically we're visiting of n times n, so n square cells total. Let's get this solved for of n square solution first and think about optimization. So the n number of rows will be the length of the grid. And then we are going to define recursive. We can potentially just reuse this solution construct. But I'll first do the recursion. So we need row start, row end, column start, column end. So base condition will be equals range. Also the column range. I want to check if they're the same. So previous number, previous value can be 0, or it can be the value of row start, column start, and then we are comparing all the numbers. If breed RC is different from pre-value, then we know we have to break this into 4 different quad. So another volume value, same value, or I'll say true. And as soon as one of them is different, this volume value will be false, and it's going to break out of this for loop. Yeah, I think this break will only break out of this for loop. So there might be a way to break out of 2 loops. It will still work. I'll actually just leave it without the break. Just a little optimization. Okay, so we got the same value boolean. If there are same value, then we can actually create a node. Create a new node. The value will be the value of the previous value. And is leaf is going to be leaf? Yes. Is leaf 1 or 0? I'll just leave it as true. I'll leave it as 1. Top left, none, 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 none. If they're not the same node, then we're going to call recursive on row start, and I want to end in the middle point. So this would be row end minus row start divided by 2. But then I have to add this to the row start. So this would be the new end. I actually will calculate the row mean point. Will be this, and then when I pass it in like this, there's also column start. Similar to row mean. mid, there's a column mid. And then there's column start, mid. So let's think about this. When row start is 0, row end is 7. 7 minus 0 will be 3. So 3 will be added to 0. So row mid will be 4. Or 3. Because this was 3. Yes, row mid will be 3. This is what we expect. Then we call this top left. We still need to create a new node in else case, but this time it's not going to be the leaf node. And then we need to define top left to be this, because we are giving it start of the row to the midpoint, start of the column to the midpoint. And then there's top right. So top right starts with row start, row mid, but it starts in the mid of the column. Wait. Yes, it starts in the mid column and then end. And then there's also bottom left. In this case, it will be row mid plus 1, column start, column mid. Oh, we need to end and row end. And lastly, there is bottom right. So we assigned all the nodes, and we'll return new node. Then we can just return recursive 0 to length of the grid minus 1, 0, and length of the grid minus 1 as well. So let's think about this in the example here. Okay. So there's a solution, previous value, so it will try to find same value. If it's not the same value, then it's not a leaf node. Then we need to create nodes to all four directions. Yeah, let's try to run this. Ooh, I got both cases right. Should I submit it? Let's give it a try. Oh, yes. So I think this passes, even though it's of n squared time complexity solution. Will there be any better way to solve this? So I'm gonna kind of brainstorm how I can improve this operation of checking the same value, or is there any? If we think of like kind of a DP solution here, we could use the row ranges to store whether a certain range has the same values or certain rows. Or so what's gonna happen if we, okay, in this example, right? So it's gonna check each cell, and it's gonna determine all these other cells are same values except the one on the top right. On the next iteration, it will start counting again for these cells. So if we have some record of certain cells are the same, maybe we can improve.